And welcome back to the study guide for Physics 135B midterm. The next question in section 4, capacitors, is what is the capacitance of the capacitor in the previous problem? Now, keep in mind that that capacitor in particular was a parallel plate capacitor. We have a positive plate and a negative plate, separated by a known distance with a known plate area. So the relevant formula here is that the capacitance of such a capacitor is epsilon 0 times the area divided by the distance between them. That's going to be 8.85 times 10 to the negative 12 farads per meter, which is one of the unit combinations that we have for epsilon 0, the permittivity of free space. It has units of farads per meter. And it's useful here because we're going to multiply by area and then divide by distance. Now the area, we have to go back and find, it was 10 millimeters squared. And so that's 10 millimeters squared. And then the distance, I believe, was 1 millimeter. Right, the D is 1 millimeter. 1 millimeter. And so we get that the 1 millimeter factors cancels. Millimeter squared divided by a millimeter is just a millimeter. And so we're multiplying by 10, so that becomes 8.85 times 10, right, to the negative 12 times 10 is 10 to the negative 11 farads, and then we have a millimeter in the numerator and a meter in the denominator. So we have a farad times a millimeter divided by a meter. Now, a millimeter divided by a meter, what is that? So a millimeter is 10 to the negative 3 meters. And so this is going to be 8.85 times 10 to the negative 11 farads, and then 10 to the negative 3 meters divided by just meters. So the meters will cancel and we're just left with farads, but that is the unit of capacitance. And so C will just be the usual 8.85, but then multiplied by 10 to the 11 minus 3, so 10 to the negative 14 farads. Now, keep in mind, the farad is a giant unit, so like some average capacitance might be 10 to the negative 6, 7, 8, 9, 10. Really small numbers, just because 1 farad of capacitance is a really large capacitor. You would notice it would feel very heavy in your hands relative to other electrical components. So let's consider the same capacitor again in problem 2, but suppose a second identical capacitor is connected in parallel with it. So just hooking them like this is in parallel. What is the total capacitance? Well, if it's 8.85 for each capacitor times 10 to the minus 14, but we're hooking them in parallel, then the rule for parallel capacitors is that they just add. And so that would be 2 times 8.85 times 10 to the minus 14 farads. So if I round 8.85 to like 9, 2 times 9 is 18. So this is about 18 times 10 to the negative 14 farads. For part B, how much charge would the pair of capacitors store if the voltage across them was 5 volts? So the charge is given by Q times C delta V. And so if you know C total times delta V, well, you're just going to multiply by 5 volts. 18 times 5 is what? 5 times 8 is 40. And that's 20, so 200. 5 times 1 is 5. No, 5 times 1 is 5, plus 4 is 9. 90. It should be right. It should be less than 100. Okay, so that's Q is equal to 90 times 10 to the negative 14 coulombs. That doesn't look like 14. Right, 90 times 10 to the minus 14 coulombs, or 9 times 10 to the negative 13 coulombs. But the point is, to calculate the charge from the total capacitance and voltage, you have to relate them linearly like that. How much energy in joules would this charge have if it was all put to work? So the potential energy stored in a capacitor is 1/2 CV squared. So let's put 1/2. The total capacitance was 18 times 10 to the minus 14 farads, but then we're going to multiply by voltage squared. But if the voltage is 5 volts, so that times that squared is 25. So that's 25. 5 times 5 is 25, and then the units come out to be joules. So it's actually 12.2 or 12.5 times 18 times 10 to the negative 14 joules. And I have run out of calculator space in my brain, so I'm going to just quickly multiply 12.5, which is 25 divided by 2, times 18. That's 225 times 10 to the minus 14. That's 225 times 10 to the minus 14 joules. So 2.25 picojoules. Pico means 10 to the minus 12. So in other words, using this formula is the way that you get energy from capacitance and voltage. So that was the section on capacitance, and stay tuned for current, resistance, and DC circuits.